good to see all of you came to listen to my talk. I got a couple announcements. First, we want to make sure that you get some feedback to us so that we can continue to improve our talks for future sessions. We passed out some forms for you to fill out. We're going to be posting these sessions online next week. You can go to code.google.com/io, which is the conference website, and get those when they're released. And finally, make sure you join us in the after-hours event on Level 3 at 6 p.m. tonight. But you got to have your badge to attend and a wristband if you're going to be drinking alcohol. So, welcome. My name is Rafe Kaplan. I'm one of the core developers on the App Engine team. And in particular, I'm the primary maintainer for the Google App Engine model API. And that's why I'm going to give a little talk about some slightly advanced techniques that you can use when working with Google App Engine models. Okay? So what I'm going to do is I'm going to talk a little bit about some of the, give you a little bit of an introduction and talk about some of the thinking that went into the design of this API, and move on from there to discuss some of the more basic things that you need for building a data model, such as creating relationships. So I'm going to go over one-to-many relationships and one type of many-to-many relationships that you can build. Finally, I'm going to talk about aggregated properties. I'll describe a little bit later what that means, and that will be something that's very useful for making sure that your application performs correctly and has good design. Okay? So the design goals of the model class was to provide a way for users to declaratively describe models for use in their web applications. We wanted there to be one single location where you describe these models. So, you don't have to have a separate file to describe, what your schema is going to look like, another file to describe an object relational mapping, and perhaps another file that will describe, some other kinds of stored procedures or extra functionality. You can define everything in one place. We wanted this API to be object-oriented so that it would be easy for you to build in encapsulation and extend the existing types and build your own types of functional models. All right? Now, what we've done is certainly not a completely new concept. There are a number of other object relational mapping tools out there. And the most famous probably right now is ActiveRecord, which is the persistence model that Ruby on Rails uses. And Django, which is a Python-based, Rail-alike tool, is, also has its own type of model system. Our system is probably more closely related to the Django's model and the Ruby on Rails model. Java has its own, a very popular object relational mapping tool called Hibernate, which, makes it much easier to map static Java classes to tables in an SQL database. Okay? It's important to remember that the data store that we've created for App Engine is not an is not a relational database. So what we provided is not an object relational mapping. It's just an object-to-object mapping. Underneath it, we don't have an SQL database. We have a data store that is built for scalability and performance. We don't require the user to define pre-existing schemas. Everything is defined right there in the code that you're using. We want to be able to, we are able to describe these objects naturally using a scalable Python environment. And finally, the information in the data store can be heterogeneous, which means that for a given kind, you can have each object in that kind can have a different set of properties from all the others. And furthermore, even where they share properties, each of those properties can have different types between entities. Now, there are some aspects of the data store that might seem at first like drawbacks. For one, we don't allow for joins. We don't help you do the kind of 2-3 table joins that SQL tries to help you to do. We don't provide aggregation functions. This is what I mentioned before. This is when you want to perform a query and get an average of a particular attribute of that query, or get a sum or something of that sort. We don't provide any kind of server-side function calls or stored procedures, and we have limited inequality operators. But we've done it that way because we needed to make sure that this model scaled, this data store scaled, and we think that this is a very good way to achieve it. So let's move on and start talking about one of the first things you need to define a data model. It's one of the first things that comes up on our list when talking about models is how to create relationships between different types. Well, what I'm going to do is I'm going to go over a real-world example. We're going to define a simple contact database. Contacts very similar to what you might have on Gmail or what you might have using Outlook. And the first thing we want to do when defining this model is figure out what we're going to capture. We obviously want to capture some basic personal information like a person's name and date of birth. We want to get phone numbers, and we want to get a phone number for the person, and we want to get an address for the person. So we make it very easy to define this model. You just define it using a simple Python class, and we give you a number of built-in types for the data types you expect for integers, floats, strings. But we also provide a few other types. We can provide you with G data types, which you can use to integrate with other Google services. So let's go and define one of these models, right? We're going to do a very naive first try, okay? We're just going to define a class called contact, and it's going to inherit from db.model, which you import from the extensions, the Google App Engine extensions package. And all classes that are going to be used as a persistent class should inherit from model. We want to describe the basic information. We're going to define a couple of properties. These are persistent properties. So we're going to define the name, a birth date, and you'll notice the name we've defined as a simple string property, and the birth date we have a special date property for representing that. And down below we're going to give the contact an address. Now notice it's a type called a postal address property. This is one of those G data types that I mentioned previously. And similarly, for phone number, we have a phone number type to make it easy to capture this kind of information. Now, that's a good first pass, and that'll get the job done. But there's a couple problems with this model. For one, what if the contact has multiple phone numbers? I mean, probably most people in this room has multiple phone numbers. At the very least, some of you might still have a landline, carry a mobile around, or you have a work phone number on your desk at work. Or what if you have multiple addresses? I mean, what if you own multiple houses? I mean, obviously, I'm not one of those people, but you might be. And and furthermore, like what if you want to do more? You wanted to arbitrarily categorize the contacts so that you can organize your friends and your family and your coworkers and your lacrosse team. The model the way that we have it isn't really adequate for capturing this kind of information. Now, there's a really simple solution that we can use to try to fix the problem. We can just define a number of additional fields to capture all the different types of phone numbers, for example, that we expect the user to have. So here we have a home phone number, a work phone number, a mobile phone number, and that seems like a pretty simple solution. We're still constraining ourselves to one simple entity. The problem with this, though, is you'll find that you can't predict how many phone numbers the person is going to have. I mean, what if somebody invents a telephone number for a phone for a place that we hadn't thought of? Or there are some people who have multiple mobile phones. Sometimes they'll have a work mobile phone and they'll have a personal mobile phone, or maybe they'll just have two mobile phones. So and I think the most serious problem with how the data store is structured is that it becomes relatively difficult to perform searches. So, for example, let's say you wanted to find all of the contacts in a particular area code. You'd have to do 3 separate queries over all of these fields over all of these properties in order to find all of these contacts. And if you wanted to add, you would need to add another phone type for the new location for a phone. You'd have to go ahead and do that. You'd add a 4th type, and then you have to update all of your queries to do 4 queries. So really, what we need is model relationships, all right? And the simplest kind of model relationship that we provide in App Engine is the one-to-many relationship. So let's go back to the code. And let's look at the, let's go back to the code, and we're going to, go back to our contact model, and we're going to just remove the phone number from it. Because what we're going to do later on when we declare the phone number class is it's going to create an implicit collection that's going to refer to all of that contact's phone numbers, all right? And down below, we have the phone number declaration. We have another class. It also inherits from DB model, and it has a contact property. This contact property is special. It's a reference property. And this means that what you can do in the data store is store a reference to another object. This is very similar in SQL to storing a foreign key in a table, except that in the data store, keys are actually unique objects across the entire collection, your entire collection of data across all different kinds, all different, or all different tables if you want to look at it like that. We're going, so we provide the class that we want the reference to reference. We want it to belong to a contact. And we're going to provide a keyword argument called collection name. And this, I think, is an important thing that you should all do. Collection name is an optional keyword argument. By default, we create a collection for you, but sometimes that collection can be a little bit unfriendly. And what's more, if you try to define other reference properties in the same class that refer to the contact, you'll find that there'll be namespace collisions. So it's always good to provide a collection name. Okay? And we're going to add a little bit more information down here where we're going to provide the phone type. This is, just another string property, but we do something else. We provide a number of choices. We're going to constrain this property with a number of choices that limit it to homework, fax, mobile, and other. And I'm guessing, you could use other for the new location when it comes out. But it works very much like an enumerated type. And finally, we're going to have the number, which is basically replacing the phone number property from contact. And of course, we only have to call it number because it already is in the context of a phone number class. Okay, so that's how we define a one-to-one relationship. Let's go ahead and work with it. The first thing we need to do is we need to be able to create objects and then relate them to each other. Well, creating objects in the App Engine Datastore is pretty straightforward. It's very similar to how you might create any other Python object. You first instantiate it by calling its constructor. In this case, we're going to create the Scott contact. And we're going to take the Scott contact and we're going to put him into the data store. Now, the put method is something that's defined on the model class, and that's what you use. You call it on the object that you just created, and that's what you use to store it into the data store. Now, this works not just for new objects, but for when you need to do an update. When you load an object from the data store, you can make modifications to it, and then you call put again to do the storage. The data store doesn't care if it's an update or an insert. They both basically work the same way. And finally, we're going to create two phone numbers for Scott and associate them with him. We're going to call the phone number constructor, and we're going to pass in these three keyword arguments. Now, the keyword arguments, you notice, actually map to the properties that we defined on phone number. That's another feature of the model classes, is that for all the properties, we automatically, in the default initialization function for model, we use keywords to populate your object for you. That's very easy. It's a very convenient shorthand. In order to create the relationship between phone number and Scott, we actually pass Scott into the constructor, assigning it to the contact property. Remember, contact was the reference property that we defined. Okay? And we created two numbers, a home phone number and a mobile phone number. Now, we've created these records, and we need to be able to read them from the data store. Well, let's go, the really easy side of the relationship is when you need to go from, if you have a phone number, if you have a reference to a phone, in a reference to a phone number in Python, and you need to get that phone number's owner and find out that phone number is the name of that contact, it's very easy to do. All we do here is we're just going to take a phone and print out the phone number and say that it belongs to the phone's contact's name. So this does a little bit of lazy loading magic and automatically loads the contact object for you. And then you can refer to the name property just as you would any other Python attribute. Now, if you want to get all of the phone numbers for a contact, there's a few ways you can do that. The basic way that you do it is through a GQL query. Now, GQL is a simple language that we created to make it easier to query information from the data store. We decided to make it similar to SQL so that it would be as accessible as possible to new users. And it should look very, there it is on the screen. We provide on the model class a helper function called GQL that helps to narrow your GQL search to focus on a particular class of objects that you want to retrieve. So in this case, we're calling the phone number as GQL method, and we don't have to put the select part in because we're calling it on the object, on the class. It automatically does the select from phone numbers for us. And we're going to do where contact equals :1. :1 is a positional parameter, which, as you can see, we've passed in Scott as the first parameter to this function, to this method call. We're going to order the results by phone type and number. Now, you usually want to do that because if you don't provide any ordering, you could get arbitrary results back from the data store. And now, the GQL method returns an object of the type query. Now, I encourage you to go and look at the query object, the description of the query object in the documentation, because this class is one that you want to work with a lot, especially if you need to restrict the type of information that you want to get back whenever you have access to one of these. And we use this in several places. GQL is one of them, but as you'll see, we use them somewhere else down below. So when you have a query object, you can tell it, I want to fetch 10 objects. It'll go query the data store and come back efficiently with up to 10 objects. Now, obviously, Scott only has 2 phone numbers, so we're only going to get 2 records back. But if he had 11 objects, we would get the first 10 according to the sort order that we specified. But a slightly more intuitive way to go about retrieving information is to actually access that virtual collection that I described that was created when we specified the reference property on the phone number class. So here what we've done is we're just going to iterate over Scott's phone numbers for phone in Scott.phonenumbers. And now recall, this is another place where we return a query object. Phone numbers, this virtual property, actually returns a query. So we can add sortings to it, and we can filter it, narrow down the things that we're looking for. So, for example, perhaps we were only looking for mobile phone numbers. We could get all of Scott's mobile phone numbers using a filter, which I'll show later. We iterate over this, and we access the phone number just like we would any. We access information about the phone number just like we would any other Python object. And it's very, hopefully that's very intuitive. Now, finally, we need to be able to delete the objects. We need to delete the objects and discontinue the relationships between them. Now, the simplest form of deletion is when you want to remove a phone number record from a contact. This is easily done by retrieving the phone number object and calling that object's delete method. Here we've done it. We use the Scott.phonenumbers property again. And this time we apply a filter, because we're going to narrow it down to only his mobile phone numbers. We apply a filter on the phone type property and filter on the constant mobile. We're going to call get, which will, in this case, we're going to get just the first instance that comes back in the query. And in this case, it's okay, because we know Scott only has 1 mobile phone number. And when we have that object, we can then call the delete method on it. But that can be a little complicated, since one of the things that we don't support in the data store is we don't have server-side triggers. You'll want to add some extra functionality to your objects to make it easier to garbage collect entities that you need to remove. So let's say we're going to delete Scott from our Rolodex. To make it easier, it makes sense to override the delete method and put a little bit of extra stuff in there to iterate over all of Scott's phone numbers and call delete on all of those records. Then we're going to call the superclass's version of delete, which will act the same way as it does for the phone number. But so that's the simplest type of relationship that we provide. But now we want to be able to categorize our contacts. Let's say one of the things we want to add to our application is to send a text message to all of our friends, or we need to send a text message to all of our coworkers. We want to be able to organize our contacts into groups. We might want to keep additional information about these particular groups, like we might want a longer description that might have additional instructions that are useful to us, but I'm sure you can imagine other models that'll have more information that it needs. We want to allow the users to define any type of groups that they need, so they can invent new ones. A typical one might be friends, family, and coworkers. And we want users to belong to more than one category. It does happen that on occasion you have somebody who's a coworker and a friend, but every once in a while. But anyway, the simplest approach that we have, and the one that we would like to suggest as probably the most efficient way to do it, is to store the many-to-many relationship as a list of keys. Okay? What you need to do here, it's a somewhat asymmetrical relationship. You choose one side of the relationship to contain that list of keys. And what you want to do is you want to pick a side of the relationship that typically is going to have fewer members on its side of the collection. So I'm going to choose that the list property is going to go onto the contact, because typically, if you're very popular, your friends category is going to be quite large. And but it's not likely that you're going to have that many categories. It's not likely that Scott's going to be a friend, coworker, family, and a million, fulfill all the other the hundreds of categories that you define. So for performance reason, it's best to keep that list on the sort of small side of that collection, right? So what we do then is we use a new property type called a list property type. And we're going to define a new property on contact called categories contact is in. And when you define a list property, you have to specify what type that list is going to be. Because data store lists have to, all are composed of the same element. So if you wanted to have a list of integers, you could have a list of integers. If you wanted to have a list of strings, you could have a list of strings. But you can't have a list of strings and integers. You can have a list of keys, which is the basic reference type that we use in the data store. So we're going to then define a category class. The category class has a name, the name that's going to be a short name, and it's going to have a description. But we also want to augment this with our own little virtual property to make it very easy to get all of the members of a given category. So all we do is we define, I've defined a little property by defining a method called members and using the property decorator on it. And it returns a GQL query. And what we do is we query against contact, where categories contact is in is equal to the first parameter. And what we're going to do is we're going to get the category object instance that we're calling and pass in that category's key. And that's how you're going to link all of these. That's how you're going to link these objects together. Now, it's important to point out, you might have noticed something a little bit strange about the logic here. You might think that if we're storing lists, that if you wanted to retrieve by a list, that you would specify the whole list in your query parameter. So if you stored a list, say 1, 2, 3, you might need to search where list equals 1, 2, 3. But that's not the model that we pursued for data store lists. We chose to go with one that was more closely related to a tag cloud, whereby it's sort of more of a set. So if you wanted to query on, when you query against a list, you query with one value, and it matches against any list which contains that value. So in this case, if you think about it, if you store a bunch of keys, to categories on a user, when you query against that category, you'll match all the keys in the different users that belong to that list, all of the contacts that belong to that list. Okay, so let's work with a many-to-many relationship. So what we're going to do is we're going to add Scott to both our friends and our coworkers list. And that's pretty easy to do. We're going to first create two categories. We're going to create the friend category. We're going to create the coworker category. Both of them, make sure you store them into the data store before you try to make a relationship between them. And we're going to take the Scott object, and access the categories contact is in property. Now, the categories contact is in property is a simple Python list. And all we got to do is add a key, is add each category's key to that list, and that completes the membership in the relationship. Now, I must warn you, one thing you might have noticed is that the keys are not type safe. So you could theoretically store, theoretically store a phone number in your category, but it's up to your application logic to prevent that from happening. It is not inconceivable that in the future we will provide some additional tools in our API to make it a little easier to do this, but for now, this is probably enough to get you by. So once we're done adding the two categories to Scott's categories contact is in list, we can store Scott, and that's it. Those relationships are created. So we then want to be able to read the many-to-many relationships. We want to be able to find out what category Scott is in and find out who are members of each of the categories. So to get all the categories that Scott is in, you need to access the list of keys and fetch all of the entities that those keys represent. The DB package provides a get method that can take a list of these keys and in one request get you all the keys that you need. You can then iterate over these keys, and then you just have a list of the entities that you've been trying to retrieve. To go the other way, to find out the membership of a group, you can use the virtual property members that we defined. Now, this is good because especially we have very large group, like let's say your friends, for that contact become very large, it's very easy to use this query to efficiently iterate over a relatively large collection. In this case, all we're going to do is we're going to get all the members, order by name, and print out that member is a friend of or a friend of mine. Deleting the relationships is also pretty simple. Since you're dealing with Python lists, all you got to do is you got to go to the contact that you want to remove from a category and get a reference to the category you want to remove them from, and remove that key from the list. And Python provides a method to make that relatively easy. You just call remove. You store the Scott instance, and there you've done it. You've removed Scott from the given category. But there's one thing you got to be careful about. You have to be a little bit careful about dangling queries, I guess they're called, where if we actually, at this point, deleted the coworkers category, there would still be references from the Scott record to the old categories that are no longer there. If you try to go and fetch those records, you'll actually get a none back if it can't match the key. So when we delete a category, we probably want to make sure, just like we did in these one-to-many relationship, that all of its relationships are properly cleaned up. One of the ways you might do this is, again, by overriding the delete method, iterating over all of the members, and removing that category from that members list. And then, of course, calling the superclass's version of delete. Right? But again, in this particular model, I think you need to be wary of trying to create very large collections. This is not the only way to represent many-to-many relationships, but we think that this is the simplest and will probably address most of the cases out there. But we're hopeful that, as time goes on, more developers are going to find different ways of working with this data. And the hope is by showing you these introductory forms, that'll get you started on how to think about these kinds of things. Okay? Next, we want to cover aggregation properties. So I said before, we don't have ways of dynamically getting a count or an average of a property of a given collection or a given query. Well, I'm going to discuss really the best way to do this. You have to do it a little bit differently than you would in SQL, and it might seem inconvenient at first, but this is how you get your applications to scale. All right? So the next use case is, do I call my grandmother enough? Well, so whenever I call my grandmother, she's always, she says that I never call her enough, right? Which is very typical. I could call her one day and she'll forget. My grandmother at this point, bless her soul, doesn't remember that much anymore. Don't get me wrong, I love my grandmother very much. But what would help me is if I can build a case for my grandmother that, in the past, in fact, I have called her on occasion. So one of the things I need to do is be able to count the number of phone calls, so I can say, oh, yes, I called you 3 times last month, or, keep track of their duration so I can, tell her, remember on your birthday I called you, it lasted an hour and a half, and, and if she complains, well, that was only one exception, well, I can point to eventually averages saying that, actually I usually talk to you for an average of 34 minutes. So I think, that's pretty good grandma time. So first thing we want to do is we need to define what our call object is going to be, the object that we're going to collect information about, right? So the first thing we want to do is we want to record the date of the call and the duration of a call. As we already went over, this is going to have a basic one-to-many relationship with contact, which you should be familiar with by now. We're going to create a virtual property on contact called calls, so it's very easy to access the calls of that contact. And then we need to figure out how to do averages and totals. Well, how SQL does it is you use aggregated functions. So, for example, if we had a similar table, we could easily get the call of accounts by doing select call star from calls where contact equals and your grandmother's primary key. That would be my grandmother's primary key. Similarly, to get the average, you want to do the average over the duration column, and that's how you do it there. But let me talk for a moment about how not to do it on Google App Engine. The most intuitive way that you would do it is you would simply iterate over the objects and do the math right there in the process. And it seems like, it's very tempting because we've come up with these, nice, ways of navigating your object model. The problem with this is that iteration, this is also very good because it can produce dynamic results. But the problem is that this is the number one way that you can burn up all of your processor quota. And you burning up your quota is not something you want to do. It's not something you would want to do even if you weren't using App Engine, because you don't want to write an application that's inefficient, because that will add on to your costs, no matter how you try to scale, right? Another problem is on the query object, you'll find that there's a count method. You probably don't want to use that because that method isn't necessarily that efficient either. And that's because of the way that we store information in the data store. Don't forget, the data store is a distributed storage mechanism, and it would be very difficult for us to go out and get all the possible bits of information that you need and bring it back to you in memory and aggregate it all at once. So we have another way of getting the count, which you probably should not use. So what I'm going to do, give you an example of the example of how not to do it is simply created methods for calculating the average call duration and calculating the call count. It's very eloquent, very straightforward, but unfortunately, that's not what you want to do. So here's a better way. You need to maintain your aggregate. You need to maintain your aggregate calculations as you build your model. The best way to do that is to build helper functions to guard when you create and manipulate objects in your model. So, in this case, what we're going to do is we're going to go back to contact, and we're going to add 2 more attributes. We're going to add the call count, which is going to be an integer property, and we're going to add the average call duration, which is going to be a float property. Now, I decided to make the call average a float property because we're going to do this sort of running average, and you'll get a lot of rounding errors if you don't use integers. So that's why I chose to do that here. We define a method called record call on the contact. We give a start date and a duration, and that goes ahead and creates the call object for us, does the relevant calculations, and stores it on our contact instance. And we store that in the database, and we're good to go. And that way, next time we get our contact, and I need to tell my grandmother, what her call averages are, I can do that. Okay, I'm not the best grandson, but anyway, so that's basically what I wanted to tell you guys about. And I wanted to thank you all for coming and make sure that you all have, you all know about where to find the best information about how to build data models. The Datastore API documentation is at this URL. We also periodically publish articles that talk about a lot of other topics that aren't covered in the basic documentation. And of course, you're all encouraged to go to the App Engine group. If you search that group, there's actually a lot of discussions, a lot of debate and ideas floating around about, what kind of models that you can build and how to make your data store perform more efficiently. Okay. So again, thank you all for coming. It was good to see you all. So for those of you who are interested, we're not done yet. I'd like to take questions. So if you can, please come up to the microphones on either side and let me have it. Yep.
Yeah, so looking at these data models, I mean, it's pretty interesting. You can build really highly scalable, very efficient models. But what I keep noticing over and over again is a lot of the things that used to be handled automatically now have to be done in code. Mm-hmm. And so there's kind of two drawbacks to that. One of them is you actually have to code all of that stuff. But beyond that, I'm kind of wondering, code almost always has bugs in it. And as soon as I have a bug, I'm going to start corrupting my data store. And what do I do about cleaning up? Like, suppose I ran for a month and I accidentally didn't clean up all of the links for my contacts out of the categories and whatnot. And so now I've got all these different floating bits of data around in my system. And is there anything I can do around?
Well, right now, the kind of thing that you're talking about is creating some kind of offline processing mechanism. Currently, the App Engine doesn't support offline processing. But there are probably some things that you can do to mitigate those problems. You can try to design your model, if possible, to deal with those kinds of errors when they come up. But I think that kind of thing is really an ongoing question, and it's a question that comes up a lot in the groups. And there's a few other different ways that people are thinking about doing it. For some of the batch processing, you might want to look at how the bulk uploader works. That might be a model that you can use for batch processing. But you need to be very cautious about when running that, because that's one way that you can use a lot of your CPU quota and those kinds of resources.
So it sounds like your other suggestion then is to verify my data whenever I read it. And if I find it to be inconsistent, then I can do a cleanup at that point.
Well, unfortunately, I don't know if you can find a way of doing that without loading all of the elements that you need to do the calculations, then you can do that. But if you try to do the check at every time, you might as well do the calculation at the same time.
I'm curious. I'm not an engineer, but it seems to me that when you have the phone number property reference the contact that breaks object orientation, wouldn't you rather do a list property on the contact and say, oh, I need phone numbers for this?
I'm not sure if that necessarily breaks object orientation. It does seem a little bit sort of SQL-y, I admit. But since it does create this virtual attribute, I feel that that's a pretty good proxy for the concept of having a list on that object. I don't know if that answers your question.
I mean, it seems like the whole idea of virtual collections is against object orientation. It seems like you ought to have all your properties of an object listed in the object and not have other properties worry about where they might belong in your application.
Okay.
Just curious.
Ours is not the only model that you can use, and if people can define better ways of doing it, that could be an excellent contribution to the community.
Thanks. I just wanted to ask about when you have a model and you wanted to query a part of the model and do a partial text match. Mm-hmm. Is that if you wanted to say I wanted to find all my friends whose first name started with S, mm-hmm. Maybe you had a control across the top and your address book. What would that be through the model API itself, or would it be through the query part, or where would you go within the App Engine to make that kind of in SQL world you want to do like a like function with the percent afterwards?
Yeah, I understand. I don't think that we support that kind of query, that kind of matching yet. And if you can predict the part that you're going to query on. Like let's say you have a field that's first name and last name. What you would do is you would break it down into other properties that are searchable. So again, you would be somewhat limited in the kinds of queries that you can do, but it could probably address most of the types of queries that you'd like.
Yeah, I mean, if you've ever done like the jQuery concept of, as type ahead and it sort of IntelliSenses the contact from your list of lots of contacts, if you're typing the last name, W, X, it would sort of limit the list of all the W's down to the people. Yeah.
I'm sorry, could you go, if you want to contribute, can you go to the microphone?
Earlier today, Ryan had a talk on the data store and how it works, and he used that example. So maybe you can go back to when they published the videos or something of these conferences and go look for the earlier talk about an hour ago on the Google data store and how it works. And he tells you how to access it like that. You basically give it a Google query that says, select everybody with name greater than B and less than C, that kind of thing.
Right.
You kind of given us a sample of some of the data types. Can you give me an idea of approximately how many data types there are, and are there any special scalability concerns for specific data types?
Right now there aren't any. I don't think there are any specific scalability concerns. You can actually look up all of the data types in the data store documentation that I posted on the stream. It'll show you all the different types. There's two types that can help you scale. There's the text and the blob type. The interesting thing about those is that those are non-searchable properties. So if there's a property that you don't need to search over, you might choose to store information in those kinds of properties because you'll save on building indexes. But that's the main thing that I can think of.
So you've basically suggested that for aggregate functions like summing and counting, since we actually don't have aggregation functions, that instead we define new properties and then maintain those properties in code.
Yeah.
Are there any plans in the work to maybe introduce new property types? That it seems like every time I want to maintain a count of the number of other objects, that my code is going to be practically identical. I'm going to increment the value of a property and put the object. Couldn't it just be a count property that referenced to the earlier property, and then that could all just kind of happen for you?
Well, I can't say that that we're necessarily going to support that right away. I don't actually know, but these are the kinds of things I have been thinking about. And one of the things I was thinking about talking about today, but didn't know if I had enough time to do, were how to extend property types. It is our intent that users look at the property class that we provided in the model API and write their own properties. And there's basically, if I don't have the class on hand, but there's basically 4 methods that are useful on that class. If you look at the source code, that will describe what you can do. And the main thing is, I don't remember their exact names because they're very long and descriptive, but there's like make value for data store and get property from data store, which are used for mediating between the primitive data store values and the Python value that you want to store, because you don't have the ability to extend the core types inside the data store. And then there's also one that that defines what it means for a value to be empty, and one other.
So that's currently possible to define your own property type?
Absolutely.
Awesome.
Yes.
All right. Problem solved.
Yeah.
Thanks.
One of my concerns when I look at the examples is that my data model is intertwined with the code for my application. So let's say, for instance, I'm fantastic. My Google app is fantastically successful, and I've got millions of entries in my database now. and maybe I'm going to do some offline processing, and I'm starting to write a lot of code. And if I have to search back through my code to try to figure out what my data model was, rather than having it exposed as some kind of general declarative description of the data model that all of my code can reference. Maybe some of it later when you support Java will be in Java and some will be in Python or whatever. That I'm going to start having some trouble as I scale up my application because my data model, my code are all interleaved. What is your viewpoint on that?
Well, it's true. The way that we've defined the model API, it is you might end up, depending on what kind of design decisions you make, intertwining your data with your code. I have seen somebody who probably thought more closely to you and went up with his own way of defining models. So again, if the user community doesn't like how we've defined these models, I expect we're going to see new kinds of inventions to do it closer to the way you like. Let's go to this side.
Hey, at a couple points during the talk, in some of the examples that you gave where the code construction was iterating over a result set, where you constructed it as, say, for contact in some query.fetch, and then some operation. You mentioned that was in some way more efficient.
Yeah.
Is it more efficient in just kind of a coding notion, or is it using a generator that's streaming data from the data store? Or
yes, when you do that, when you get a query object, the query object has overridden the iter method, and that will iterate efficiently over a result set. It basically prefetches, I think right now 20 objects from the data store before needing to go back for more.
And does it somehow get around the 1,000 result limit, or is that still in place?
I believe the 1,000 result limit is still in place.
Thanks.
What are the efficiency issues in using the reference property? Does it always take a seek to dereference, or is there an index that's already got some of that serialized?
That's a good question. There can be, if you are not careful with your dereferencing of the reference property, you can end up with some problems. For example, we do not yet have a first-level cache for objects that come from the data store. So if you keep calling this on the same object, and if you keep dereferencing the same entity from the same object, it will be efficient in that the first time you fetch it, it does the lazy load, and then it keeps a reference to that object. But if you have another object that points to the same entity, and you follow up on that one's property, it will fetch the same record again. That's something that most likely we will be addressing in the future. I can't say for certain, but you might want to be careful there. That's a very good question.
Thanks.
Okay.
Hi. I worked with a couple of object-oriented databases before where when you create a new version of a class, the pre-existing persistent object of the same class get corrupted, or you have to follow some specific rules. I'm curious to know how Google App Engine Data Model handles this.
Handles corruption?
Yes. I mean, if you want to add or delete a property to an existing class, what happens to the pre-existing objects of the same class?
Okay. Well, the existing objects stay the way they are. Is the basic answer. There can be for the time being, there can be a little bit of difficulty extending records in your object if the property that you're adding has a required value, because if it's not required and the model API doesn't find doesn't find a value for that property, it will automatically set that value to none. So it's not a problem when you add non-required properties, but if you add a required property and it finds that it's not none, that can be an issue. But that's something that we'd like to do better at. As far as deletion, if you delete a property, you will have all of the existing objects that you have created that have that property will continue to have those properties. Eventually, again, it's something you would like to clean up, and eventually we'd like to have a way to make it easy for you to do that. But it won't interfere. It certainly won't interfere with the operation of your object.
Is there a best practices guidelines on this, extending or changing an object, changing a class?
I don't think that I'm the best source for this. I think that most likely people will be discussing this on the groups. And I encourage you to look there.
Thank you.
Sure.
So there's the Google App Engine sort of model that you just described, and they're sort of doing the same thing with the Django stuff, which we saw earlier this morning. Is there a quick summary of the advantages and disadvantages of the two approaches to doing modeling in App Engine?
So the two approaches of modeling App Engine?
Like using Django.
Yeah. Oh, you mean when you're using Django forms?
No, when you're using Django to do your modeling, where you're extending the Django model rather than the Google App Engine model.
I'm not sure if are you. Oh yeah. What's the advantage? I think the main advantage is that you're able to work. It's basically compatibility with Django. Otherwise, they are the same thing.
Okay, they're the same thing. Okay, thanks.
Right. Two short questions. First, on the extension of data types, maybe if you publish the slides, could you add a few slides on how to do that? So
on the extension of,
if you have a data type like
the extension of properties. I don't have any slides right now, but I think if you go to the article sections over time, there will be articles that will come out that will describe more of these things. As I said, we just touched on a few techniques, and I think during my practice it took me a little longer to get through it. So.
Right. And the other question is, if you have a list of keys, just how many keys can you put in there?
I think that if you're going to create a list, it's probably best to keep it under 100 elements.
Okay.
But I don't think that I'm not aware of there being any hard limits, except possibly size limits.
Okay.
Is there any support for full text searching? Like, say I want to index text of hundreds of books. Is there any support for that?
We don't do that correctly yet, but we have something that that is sort of a hack. If you go to the google.appengine.ext search package, you'll find that there is a set of classes in there that can help you basically emulate that behavior.
So would you just return as many rows as you can, or objects, and search through them and get the next set? And is that?
Well, basically, when you store the object, it automatically does it automatically pre-computes the indexes on your searchable properties. So it won't index text properties and blob properties, but it will index string properties and integers and such.
If I define a hierarchy of classes in the models instead of deriving them all directly from model, then I understand that I will have told the Python environment about the relationships between the model classes. I'm wondering if any of that knowledge of that hierarchy carries over to the data store, so that, for instance, if a dog class is a subclass of an animal class, and I search for an animal with a given property, will that search be able to return that instance of dog?
Well, the simple answer is no, it won't, the way that it's currently written. But what you're asking about is what I like to call polymorphic queries.
Right.
And there's definitely a way to make polymorphic queries work. But that's going to take a little bit of time, and there will at least be an article about it, if not support for it.
Okay.
Oh, any more questions? Okay.
You mentioned being able to extend the property class and to call get value for data store, whatever it's called. The documentation just says it returns what's supposed to go in the data store, but doesn't say what format. Like, is there a limitation? Is there a set of data types that you can put in the data store? Is that just is it basically string and blob, or is there?
It's limited to the types that are the primitive types that we provide, including the GData types. If you go to the documentation, you'll find, if you go to the data store documentation, it will give you a list of all the different types that there are and give you their Python equivalent. If you return any one of those Python equivalent objects, they will be stored correctly in the data store.
Well, a lot of those types actually map down to the same thing in the underlying data store.
That's
right?
true. They do. Particularly, phone number does map down to string.
Is there a list of the reduced set of types? I think there's one in the code if you dig around, but it's.
I don't know if there is a list, but basically everything. It's mainly strings, geopoints, floats, integers, and if Ryan was here, he would know a little bit better than I would, but it's text and blob, I think. But I don't know if there's an absolute list of what the very, very basic types are. Okay.
Are there any special considerations for whether or not, or whether I'm reading versus whether I'm writing a lot of data? And can I expect writes? For instance, I'm doing a bulk upload of all my data. Can I expect reasonable performance from that, or is that
for writes?
Yeah, right.
Well, the performance of the write will depend on how many how many composite indexes you've defined on the class, which is going to be, defining indices is beyond the scope of this discussion. But in general, reading is going to be very, very fast compared to writing, and that's probably true for most databases. Yeah.
I have a clarification question on deprecating data models and migrating data. So you said that if you change your model, the old fields will sort of stick around, and your new fields will just get tacked on. And that's all fine, but what happens if you actually change a property type from string to integer or something like that on an existing field? Does that just get handled gracefully on the conversion from entity to model, or does it mess things up, or what are the implications?
I think the simple answer is that I think that could mess things up the way that things are. Again, it's something that we really do want to work on. Obviously, if you're converting from integer to string, I think that won't be too much of a problem. I think it will automatically convert up to automatically cast up to a string. But I don't think I haven't had time to do a lot of testing with different types of conversion models. But yeah, that's something we want to improve on. But I think the short answer is I think it will be a problem.
So is there a plan for just a general migration architecture? Because I know there's the bulk load, which is pretty good. But there's no real bulk delete. I mean, I just I had a bunch of data in there, and I just wanted to rename the class from some sort of silly name to my final production name. And all my existing data had the old class name, and I could migrate it, I could delete it, but I'm not finding the tools to do that, or even really good samples for it. And I'm just wondering what the plan is for that.
Well, it's true. We don't have a lot of support for that yet. There is a poor man's solution to if you need to reset everything in a given type. It might not be what you're looking for, but what you can do is if you override the kind method, it's a class method on model. You can specify another kind, and even though it might have a particular class name, it'll store your new records in that other kind. When you do GQL queries, you have to query against the kind, but that's sort of a poor man's delete, and that's obviously not an adequate solution in the long run, because eventually you theoretically fill up your data store with information that's hard to delete. So, again, we are working on that.
In SQL, you can return, let's say that we've got a blog with titles and content for posts, and the posts are large amounts of text and blobs. You can just return the titles to create an index on your page, and then the query from the database is only pulling the titles. When you're doing the GQL queries, it fetches the entire object if you're fetching 50, right, or something like that?
Yes, it always fetches the whole object.
Is there a guideline for when it's not a good performance idea to do that?
To fetch the whole object?
Right.
Well, I don't think there's another way to do it in Datastore, but I think that you can run into some performance issues if you have objects with a great number of fields, especially if those fields are very heavily populated. So sometimes it might make sense to do some kind of containment, whereby you break out some of those fields into a component, another component class that is stored in another kind.
Okay. All right. Thanks.
Any more? Well, we have 20 seconds left, so I think actually timing was pretty good. But I really thank you all for coming, and thanks for the questions, and I hope that you learned something from all this.